we've looked at lists quite a bit. Here's a list. I can put in some initial values. I can do things like print the list, of course. I can ask for the length of the list. I might as well go ahead and print that out. And I can take individual values. And for starters, we'll just print one of those out. Let's see what the fourth value in the list is. All right, so here's our list. Here is the length of the list, 8. And then the fourth value is 54 right there. Now I say the fourth value, what I really mean is index 4 value, right? Index 0, 1, 2, 3, and then 4 right there. We can, of course, also change the values. So I can change numbers bracket 4 to be something else. All my other numbers are less than 10, so I'm going to make this 9. And then if I print it out again, I'll have a 9 there instead of a 54, right? So 54, and then I have 9. So a list is a very common data structure, and a data structure is simply a way of organizing your data. And there are various operations usually that these things can do. And they have different features. So we're going to look at a different data structure today, called a dictionary. So the way to create a dictionary, there are a couple of ways. I'm going to name my dictionary just dictionary for now. That is not necessary, right? I can name it, anything that I wanted, but I'm going to name my dictionary. And one way to create a dictionary is with a set of curly brackets. So instead of a list, which uses the square brackets, I'm going to use curly brackets. Now we noticed right here on line number 8 that I could say like numbers bracket 4 equals 9. You can use that same notation to say dictionary bracket something equals something else. Except you can do a little bit weirder thing with dictionaries. You could use a number. Actually, I'll start with a number just to demonstrate that. So dictionary 4 equals, and then I'll say after 3 and 4, 5, right? It's a dictionary, right? It ought to define what I'm putting in it. That is not actually the purpose of a dictionary, but this is going to be my example here. And then if I go ahead and print dictionary 4, it should print out after 3 and before 5. Right, so there it goes. So far, this is exactly the same as a list. The only difference is there's these curly brackets right here. So here's where it can be different. I'm going to add something new to my dictionary. And instead of using index 4, I'm going to use index aardvark. I'm going to index into my dictionary with a word, with a string, aardvark. Now, what is an aardvark? Well, I don't know. It's a small armored mammal. I can also print that out. I can print that out by indexing with, now I'm not really indexing, right? I'm using that terminology because that's what we've seen with lists. But really, I'm just using what's called a key to get a value. Use a key to get a value. Run that. And of course, when I index in with aardvark, it prints out small armored mammal. So what a dictionary lets you do is it lets you use keys that are not necessarily numbers. Now, also, the other thing is like, if I did, instead of numbers 4 equals 9, I did numbers 100 equals 9 and ran that, I get an error. I get an index error. List assignment index out of range. My list doesn't go up to 100 different values. So I can't say that the 100th value is 9 if my list doesn't go up that far. But a dictionary has no such problem, right? This is an empty dictionary right here. And I said, oh, the value at 4 is going to be after 3 and before 5. I said that the value that I'm going to associate with aardvark is going to be small armored mammal. So what I'm doing here is I'm creating key value pairs. It's like a list, except instead of using an index, I use what's called a key. The key can be a number, just like with a list, or it can be a string, or it could be something else. I could even do an index of 3.14, or a key of 3.14, and say rough estimate of pi as my value. And then we'll also just print that one out just to verify that that works. Right, rough estimate of pi right there. So what you're seeing is I can use as my key anything that I want. It can be a number, a decimal, a string. You could even use more complicated objects if you wanted. I don't recommend that. Usually, your dictionary is going to use strings. If you were going to index with numbers, like probably you could just use a list, unless you have some weird reason why you want to use the key of 4, but your list doesn't want to hold at least 5 items in it. Typically, you're going to use strings, which is why these are handy, right? We might want to associate a definition with a word, for example, and we could put more of these things in. Now, before I go ahead and actually, I think you get the point. I mean, I could put in, I don't know. So we have an A word. Let's get a B word, a baker, one who makes baked goods. Right, we can sort of define lots of different words and put them in. But let me show you some other things that we can do with dictionaries. I'm gonna get my list out of the way here just so our code doesn't get too long. So suppose I want to print off all the values that are in a dictionary. What I can do is I can say for value in dictionary, no, sorry, not in dictionary, but in dictionary.values, right? So the same way that a list has some things that you can do to it, like get the length, things like that, you can get a list of all the values that are in a dictionary, and then you can print them out. All right, and just to demonstrate this is what's happening, I'm gonna get rid of all these print statements. So we're just gonna print all the values. Name values is not defined. Okay, I had a typo there. Right, I used value as my variable, and then I wrote values right here. So I just get rid of the S, try that again. And there we go. It prints out all the values that are in my dictionary. And value, like, that's what it is. It's a value, but this is just a variable like any other variable. You can name it whatever you like, right? So there you go. I got the same exact result if I run it there. I could also print out what are all the keys that are in my dictionary. And hopefully you won't be surprised to learn that you just use the function keys. And that gets a list of what are the keys that are in my dictionary. So let's go ahead and print all the keys out. So I get 4, aardvark, 3.14, and baker. I can also use the keys to get the values out, right? So if I could loop over all the keys here, I could print out something more complicated. I could print out key, and then what is the key? And then value, and then what is the value? And the way I would do that is dictionary bracket key, right? I access the dictionary in the same exact way that I access the list. I just get more flexibility with what I use to index in. And again, it's not really an index. We're going to use the terminology of keys and values. So I run this, and now I've got a nice little line here that's saying, okay, here's the key, it's 4. Here's the value, it's after 3 and before 5. Here's the key, it's aardvark. What's the value? Well, it's a small armored mammal, and so on. That's an introduction to dictionaries. Why might you want to use one of these things? Well, often I get questions about inventory systems. Right? You're creating some sort of text adventure, and you want your character to carry around various different items. So like you want them to have a sword in their inventory, and maybe it starts off and they don't have a sword. They're going to pick it up later, right? They're going to have a sword though. They're going to have a helmet, and they're going to have some armor. We'll just do those. What's handy about this is if you were doing a list, right? If you had inventory list, I'll just name my variable that. And okay, let's put in some values here. So your sword, and this could be an object, right? It doesn't have to be a string or none or anything. It could be something more complicated. I'm going to use strings just because I haven't created an object, but this will be Excalibur, a helm. I can't think of any famous helmets, so I'm just going to call it famous helmet. Well, famous armor too. Gosh, does anybody know any famous armor?
Chainmail.
Chainmail. All right, classic. All right, here we go. So what I can do is I can say, like if my character's armor is chainmail, then I don't know, reduce their damage, right? Reduce their damage by 1 or something like that, right? And I don't have to keep track. If I was doing that with a list, and I had these same items, if I have the same items in my list and I want to check and see if my character has the chainmail on, I just have to remember that index 2 is chainmail, right? It's not actually shorter. It's just organization. It's just saying, oh, well, you have to somehow figure out that 2 is associated with the armor and remember that always, forever. And that could be really confusing or difficult to read. Like, what if you accidentally, you have a typo and you're picking up a new armor? Don't the samurais have some kind of a lacquer armor? Lacquer armor? Is that a thing? I don't know. You know, what if I'm trying to put that in and I accidentally put it at, you know, index 1? Right now, I'm not actually checking my armor at this location. It's much less likely that I'm going to make the mistake of like typing in helm right here associated with my chainmail, right? If I'm paying any attention at all, this is clearly going to be my armor. It's not like you can't do all this stuff with lists. It's that it's much more convenient to organize your code and to have your code be readable, right? This right here almost looks like if inventory of my armor is chainmail, then damage reduced by 1. Right? That's almost English. Whereas with just the number, right? Inventory 1 equals lacquer armor. Inventory, if inventory 2, like what do the numbers mean, right? Dictionaries oftentimes help us with the meaning of these things. Like I said, they're also useful if maybe you don't want to have 4 or 5 or 10 items in your list, but you want to say that like the number 7 is associated with whatever particular thing it's associated with. A lot of time, and dictionaries are extremely common. I know we like went through lists first, but dictionaries are an immensely common data structure, right? You'll have like contacts frequently, and you'll say contacts bracket, you know, maybe you'll have a person in there, and that'll be associated with a bunch of data about that person. You know, maybe you'll have a class person, et cetera, et cetera, et cetera, right? And then you'd have, you know, in your contact book, this would equal an actual person with all their information put together. This is an extremely common use of dictionaries, is for something like a contact book, anything where you're associating some particular key with perhaps a complex value that might be an object, but also your key is a little bit complex, right? You want to be able to look up this person based on their first and last name. You don't want to have to try and figure out, you know, what number is associated with this person. That might be totally arbitrary. But now you have something that's not arbitrary associated with the value of this person. And again, the terminology that I'm using is keys and values. The value is what goes into the data structure. The key is what you use to access the data structure. But dictionaries, pretty easy to use. Also, just Google it. If you have some questions, right, you'll find lots of tutorials that go right through them real quick. Create it with curly brackets. Access it the exact same way you access a list with the square brackets. But now you can use more complicated things like strings or even decimals if you wanted. I've almost never done that, but you could, as your key, as your index to find a value in the dictionary.